Who do you think is the most extraordinary scientific mind that humanity has produced?
There is no contest. Isaac Newton.
Explain why.
Okay. He, working alone, discovers the laws of motion. Then he discovers the law of gravity. He then discovers the laws of optics. He does all of this. Then he turns 26.
Let's pause right there. No, Sir Isaac Newton did not work in isolation. Mr. Neil deGrasse Tyson highlights 3 major scientific contributions. Let's break them down individually and explore whether Newton truly worked alone, or if he stood on a foundation already laid by centuries of thinkers before him, many of whom came from the Islamic Golden Age. 1. Laws of motion. The concept of inertia, a key part of Newton's first law, was not new to Newton. Centuries before him, a Muslim polymath named Ibn Sina, Avicenna, discussed this idea in his 11th century philosophical and scientific encyclopedia, Kitab al-Shifa, the Book of Healing. He proposed that an object would continue to move unless acted upon by an external force. Sound familiar? It's the very principle Newton used in his first law of motion. But there's more. Ibn al-Haytham al-Hazan, another Muslim scientist working in the 10th and 11th century, also examined the motion of projectiles. He analyzed how air resistance and other forces affected a projectile's path and theorized about the influence of momentum long before the word itself existed in modern physics. His work was critical in shaping the study of motion. So, no, Newton did not pull these ideas from thin air. 2. Gravity. Newton is most often remembered for discovering gravity after watching an apple fall. While he mathematically defined the law of universal gravitation, the concept of gravity was already being explored centuries earlier. Al-Biruni, an 11th century Persian Muslim scholar, wrote about the natural tendency of objects to fall toward the center of the Earth. He also attempted to calculate Earth's circumference with impressive accuracy, suggesting a deep understanding of planetary behavior and forces. Meanwhile, the Banu Musa brothers, 9th century scholars based in Baghdad, discussed how the same force that acts on Earth also influences the celestial spheres. In other words, they proposed the idea that the heavens and the Earth are governed by a common physical law. That's not just poetic, that's universal gravitation, in essence. These ideas predate Newton's Principia Mathematica by 600 years or more. 3. Optics. Before Newton studied light and developed his theories on color reflection, one man had already revolutionized the field of optics, Ibn al-Haytham, known in the West as Al-Hazan. While every ancient thinker like Aristotle, Ptolemy, and Galen got it wrong and had misguided ideas, such as vision resulting from rays emitted from the eyes, Ibn al-Haytham corrected this through experiments and logic. He was the first to propose the intromission theory of vision, that light enters the eye, not the other way around. He compiled all this research in a groundbreaking 7-volume treatise called Kitab al-Manazir, the Book of Optics, which laid the groundwork for modern optics and influenced European thinkers through Latin translations centuries later. Newton later built upon these foundations in his own work on light and prisms, even referencing the contributions of earlier scientists, as he famously stated, "If I have seen further, it is by standing on the shoulders of giants." And many of those giants wore turbans. No one denies that Isaac Newton was a scientific titan, but to say he worked alone ignores the global and historical nature of knowledge. Scientific discovery is rarely an act of isolated genius. It's a long, cumulative process enriched by cultures across time and geography. Ibn Sina, Ibn al-Haytham, al-Biruni, the Banu Musa brothers, and so many more. These were brilliant minds whose insights echo through the laws we still teach today, yet their names are often absent from the conversation. And it's not just Newton. There's a long, frustrating history of erasing Muslim contributions. Normally, when European scientists make a discovery, we honor them by naming it after them. Gauss's law, Euler's identity, Bernoulli's principle. But when it's a Muslim scholar, the credit vanishes. Al-Karaji's theorem, renamed as the binomial theorem, Al-Kashi's law, renamed as the law of cosines, the quadratic formula, developed through the groundbreaking work of Al-Khwarizmi, is stripped of his name entirely. And it doesn't stop there. Snell's law was actually discovered by Ibn Sahel centuries earlier. Pascal's triangle? Muslim mathematicians like Omar Khayyam explored it long before Pascal. Al-Dusi's circle, a geometric innovation later used in Copernican astronomy, never attributed to him. Jabir ibn Hayyan, known as the father of chemistry, laid the foundation for modern chemical processes like distillation and crystallization. These weren't minor footnotes. These were monumental breakthroughs that shaped the foundation of modern science. And yet, the names, the credit, the recognition disappeared. But this isn't just about forgotten history. It's about a double standard ingrained into the way we teach. When European scientists make a discovery, we're immortalizing their names. But when Muslim scholars lay the groundwork, their contributions are generalized, renamed, or erased altogether. Our education system uplifts one narrative while ignoring another. Not because one is more valid, but because one has been favored. History isn't missing the truth. It's just been hidden. Like, share, and subscribe to Truth Shall Prevail.